In solving a control problem, we have to use a circuit diagram. Comprehensive documentation is required, including most of the following: function diagram, circuit diagram, description of the operation of the system, technical data on the components. Function diagram. Function diagram is a graphical representation of the functions a product performs on its inputs and outputs. Circuit diagram. Circuit diagram shows the actual electrical connections. It depicts the physical arrangement of the wires and the components. Description of the operation of the system. It tells how the system would work. Technical data on the components tells the information on the components. Supplementary documentation comprising parts list of all components in the system. Maintenance and fault-finding information. Spare part list. This refers to the interchangeable part that is kept in an inventory and used for the repair or replacement of failed units. Two primary methods for constructing circuit diagrams. The so-called intuitive methods. It is a method in such a way that you have the ability to have a grasp on an information without the need for reasoning. The methodical design of a circuit diagram in accordance with prescribed rules and instructions.
Control chain is categorized representation of a system from which, among other things, the signal direction can be determined. Signal flow. The signal flow diagram indicates the path of the signal input through to the command execution. The signal flow presentation. Signal input, signal processing, signal output, command execution. And for classification of component, the signaling element, processing component, adjusting component, power component. Allocation of device of signal flow for pneumatic, hydraulic, and electrical engineering electronics. Input element for pneumatic, hydraulic, switches, push button, actuator, limit switches, program modules, sensor. For electrical engineering electronics, switches, push button, actuators, limit switch, program module, sensor, indicator, generator. For processing element, directional control valve, non-return valve, pressure control valve. On the other hand, contactors, relay, electronics module. Control elements, directional control valve. On the other hand, power contactor, power transistor, power thyristor. Power components, cylindrical rotors, constructional unit. On the other hand, electrical motors, solenoid, linear motor. Illustration of the structure of the control chain that show the following. The input element are manually valve, the push button valve, and the mechanical actuator valve. Second, the processing element on the processor. Third, the control element is the directional control valve, and the power component is cylindrical.
In the design of the circuit diagram, it should correspond to the control chain, whereby the signal flow is represented from the bottom to the top. If a circuit diagram is represented in this schematic form, this is known as a circuit diagram. Irrespective of the actual tubing connections of the installation, the circuit diagram structure is always the same. In a circuit layout, the piston rod of a double-acting pneumatic cylinder advances if either a manual push button or a foot pedal is operated. The cylinder returns to its starting position slowed down after fully extending. The piston rod will return provided the manual actuators have been released. And as a solution, the roller lever bulb 1S3 is positioned as a limit switch in the forward end position of the cylinder. The circuit diagram shows this element situated at the signal input level and does not directly reflect the orientation of the valve. The mark on the circuit at the extended cylinder position indicates the physical position of the limit switch 1S3 for circuit operation. If the control is complex and contains several working elements, the control should be broken down into separate control chains, whereby a chain is formed for each cylinder. Wherever possible, these chains should be drawn next to each other in the same order as the operating sequence.
Designation of individual elements. Signal elements should be represented in the normal position in the circuit diagram. If the valves are actuated in the initial position, as a start precondition, this must be indicated by the representation of a trip cam. In this case, the actuated switching position must be connected. Designation by numbers. With this type of designation, elements are divided into groups. Group 0 contains the elements for the power supply. Groups 1 and 2 designate the individual control chains. One group number is generally allocated for each cylinder. Designation by letters. This type of designation is used primarily for systematic development of circuit diagrams. Here, limit switches are allocated to the cylinder which acknowledges them.
Yon, i-discuss ko yung life cycle of pneumatic system. Ano nga ba yung mga dapat tandaan ano nga ba yung mga cycle ng pneumatic system? Una kasi papasok dito is yung control problem. Ano nga ba yung nakapaloob dun sa control problem ng pneumatic system? Una is analysis. Sabi dito, analysis. Define the objective of the pneumatic system. Siyempre, isang system, dapat may objectives ka na gustong ma-meet or gustong mangyari. Kumbaga is yun yung pagbabasehan ng inyong pneumatic system na gagawin. Kumbaga magsaset ka ng goal. Then papasok dito yung sa design. Kailangan sabi dito, develop a solution for the pneumatic systems. Kumbaga is ikaw yung gagawa ka ng design, ng process, ng plans, kung paano yung magiging setup nyo dun sa pneumatic system na gagawin nyo. Kumbaga is, kunyari is lalagyan mo siya ng gantong valve, ganyang valve, ng push button na ganto, ganyan, alin yung i-off mo. Kumbaga may design, may design kayong sinusunod. Then kasunod nun is implementations. Syempre, after mong mag-isip ng i-design, i-implement mo na yung design, dito na papasok yung construct, install, test, and commission the pneumatic system. Kumbaga is pagka-design nyo, i-construct mo na yung pneumatic system na gusto nyong mangyari. Doon papasok yung implementations. I-install mo yung mga kailangang gamitin sa isang pneumatic system. Then kasunod dun is i-evaluate mo ngayon. Sabi dito, evaluation. Check that the performance of the pneumatic system correspond the analysis objective. Kumbaga is check mo yung naging performance ng pneumatic system, yung naging behavior niya, or kung may mali ba, evaluate mo kung ano yung naging performance niya, kung good ba siya or nasunod ba yung objectives na gusto nyong kalabasan. Tapos after nun, hindi, nandito papasok yung maintenance, diba? Service and maintain the pneumatic system to perform as required. Kumbaga is dapat is ma-maintain nyo yung process, yung service, tamang service ng pneumatic system para mag-perform siya do sa gusto nyong mangyari. Tapos after nun, dito na papasok yung upgrading. Then dito naman yung upgrading is modify or upgrade the system to meet new requirements. Kumbaga is maglalagay ka na dito ng twist. Lalagay mo siya ng kaibang kakayahan or may gusto ka pang idagdag, nakukulangan ka dun sa system na ginawa nyo, parang gusto mo pang rikitan, yun, dun papasok yung upgrading na magdadagdag ka na ng mga ibang gamit para mas lalong gumanda yung pneumatic system na. Yun lang dito yung life cycle ng pneumatic system. Una is analysis, define the objective of the pneumatic system, design, develop a solutions for the pneumatic system, implementations, construct, install, test, and commission the pneumatic system, evaluation, check that the performance of the pneumatic system correspond the analysis objective, maintenance, service, and maintain the pneumatic system to performance required, and lastly nga yung upgrading, modify or upgrade the system to meet new requirements.